So this is the fun part. I've always enjoyed building analysis in Excel. Excel has a lot of powerful capabilities. If you're not an Excel user, then this is a good chance, I hope, not to learn Excel to do this problem or to do your case study, but to see how Excel can truly be beneficial in your personal life, in your business life. I know people who don't use Excel but have people working for them that do use Excel, and they're so totally completely dependent on those analysts. And Excel has its positives, also has its negatives. Most Excel analysis, especially if it has any complexity to it, there's a major error in there somewhere. And managers need to understand how Excel works, how the errors can be there, how to ask questions to test the logic. And that's one thing I'll do with your teams is I like looking at a cost benefit analysis and just looking at the answer and just asking, does that seem logical? Does that benefit seem too great, too minimum? You know, you do some back of the envelope guesses of what the outcome will be, and just testing it. And that's one thing to do with Excel is step back, test the model, see if it makes sense, change an assumption in a radical way, and see if the outcome changes in the way you would expect it to. So what we want to do when we set up, and this is important because of the way I actually assess the cost benefit analysis when I get your Excel spreadsheet, is are you using the full capabilities of Excel, which means for full capabilities, it means can you change your assumptions, and that updates everything automatically. You don't have to go in and make adjustments. So we're going to do the base case. Once we get the base case built, we'll use that to build the other cases. So just like we did in the financial applications set 5, we're going to have very similar columns. We're going to have time, just like we did before. We're going to have the cash flows, but we're going to take several columns to do the cash flows. So we'll set that up. So let's start off with time. Remember, with time, I like to start with today. That means every time you load the spreadsheet, this is going to actually change to a different day. You can see I did this the day after I did the one we did for financial application number 5. And then remember, we took that previous day and we added 183 days so that we get the 6-month period. And to that, we'll add 365 days. Now, how many years do you go out? We'll talk about this in class. Here in the actual assignment policies, their CBA policies number 2, they say they go out 5 years. So what will you do in your case? It all depends on, first of all, does it make sense to go out further than that, just because technology changes and just uncertainty in forecasting. But if you're doing solar panels usually are expected to last 25, 30 years. You'll have to go out 25, 30 years. If you're doing an electric car versus a gas-powered car, you would go out 5, 6, 7 years, whatever you think is the length of time the car is going to last. If you're doing a real estate one where it's, do I buy a house or do I rent a house, you'll either have to go out 25, 30 years, or you go out 10 years, but assume at the end of the 10 years you sell the house so that you can have some point of stopping. If you don't do that, there's almost no way buying a house will look better than renting, because you really need that resale in 10 years. There's just no way you're going to recoup the cost of a house over 10 years by the rental savings that you have. So it just depends. The time frame, if you're not sure, one thing I'd recommend is make sure you go out at least long enough so that you get the payback, unless that's longer than the life of the asset. So again, solar panels, you can definitely go out 25, 30 years. If you're doing a new business, so you might be asking, do I start a new Subway restaurant, or do I do a McDonald's franchise? Those will probably require 25, 30 years. There's so much upfront cost to those scenarios that it's almost impossible to get all your money back in 5 or 10 years. So it depends. In this case, though, we were told only go out 5 years. So that helps us in that decision. So 5 years will be times 0 plus 5 additional years. All right, so now we got to do the benefits. So what are the benefits? So we have to build up to this, and I highly recommend, there's 2 ways I've seen students do it. Either way is fine. One, I've seen students will do a schedule in the assumptions page. and it might show all the cash flow for year 1, and then the years 2, 3, 4, and 5, just take that year 1 cash flow and grow it with inflation. That's fine. You can certainly do that. I'm going to do a different approach. So it's up to you how you want to do it, but I'm going to do a different approach because on this one, there's actually a couple things I need to see separately. And I want to actually have it here. And what I want you to do, and this again gets back to the logic of the spreadsheet, I want anyone walking in and seeing the spreadsheet that they understand exactly what I do. So my first column is going to be, I'm going to do transactions. There's no transactions at time 0. That's all 1 minute. So that's 1 second. It's right now. So it's the first year we have transactions. You do not want to type your number of remember it's 80,000 transactions. We don't want to type 80,000 here because that assumption might change. So you want to hit your equal sign and go over to the assumptions and click on that 80,000. So we expect 80,000 of these. Click on that and you get 80,000. One thing to be very, very careful of is, and I'll show you, well, you'll see this in a little bit. We're referencing the page assumptions. So when we copy this over to the best case and the worst case, it's going to continue to reference the sheet called assumptions. Every once in a while, just the way Excel works, it will reference the base case. So if you ever see the sheet that you are in, we're in base case. If you ever see a formula referencing base case, you would want to delete that reference to base case. Because then if you copy it over to the best case, it's going to keep referencing the base case. You don't want that. You want it to reference the sheet that you're in. So this one's okay. It's referencing assumptions, and when we copy this over to the best case and worst case, we still want it to reference that page. Now, how do we get the second year? Well, the second year, remember, we believe these transactions are going to grow at 4%. So how do we grow that? You do the 80,000 times, open parentheses, 1 plus the growth rate. You'll use this formula quite a bit. Hit your function 4 key, so you lock that in and close the parentheses. These are not dollars. I'm going to put this formula down below so you can see it. I'll put them both down below so you can see them. It's a little easier if I do it down below, and you'll see that going off to the right, we're just going to run out of room. Past that point, we can just copy it down. But the key is make sure you have the dollar signs around the B and the 8. We don't need that on the first one because that just gives us the initial 80,000. So this is our expected growth. We want to make sure we're referencing the assumptions because cash management may come in and say, you know what, we're seeing a lot of growth. This is going to grow at 8%. So we can click the 8% and automatically everything updates. So there's our transactions. The second thing we want to do is look at the number of FTEs. So how many people do we need to do 80,000 transactions? Well, each person can do 20,000. So if we take equal the 80,000 and divide it by the 20,000, again, lock it in with the F4 function. I'm going to go 2 decimal places here. In the first year, we need 4 people. Now that 20,000 doesn't change. We're assuming these people do not get any better over time. They can always do 20,000. So there's no inflation, there's no growth. In 5 years and 10 years, we assume they can still do 20,000 a year. So when you copy this down, we'll notice that the number of people we need is going to be growing over time. So that means this operation, if we don't automate it, is going to get more and more expensive as the business itself grows. All right, so there's that function. Let me push that down below so you can see it. That's the number of FTEs. The next thing we need is compensation. Now there's a couple of ways we could do this. We know compensation is $50,000, so we could just do salary. What I want to do, since compensation is always 15% of salary, I want to go ahead and combine salaries and compensation together. You could do salary and then additional compensation separately, but I don't really see the need for that. So I'm going to start off in the first year. My compensation is 50,000 times 1 plus the 15%. I don't need to lock it in, and you'll see why we don't need to lock it in. But I'm paying these people $50,000, but I'm also giving them an additional 15% for pension plans and 401ks. So my actual compensation, again, these are dollars, so I'm going to hit the dollar sign. You notice how when it's not dollars, I don't use the dollar sign. When it is, I do. All right, so in the first year, I'm paying these people, each one of these FTEs, even though this may be 8 people, 9 people, 10 people, depending on their part-time status, but on average, each full-time equivalent gets $50,500. What do they get in the future years? Well, in the future years, remember we said payroll would increase 5%. So all we need to do, and you need to have something in your case related to inflation. That's just normal for all kind of cost-benefit analysis. We want to do everything, as you'll talk about in Philip's class in economics, you want to do everything in terms of nominal dollars. You want to actually increase it by inflation. So we'll take the 57,500, multiply it by open parentheses 1 plus inflation. Here you do need to lock in the inflation, so hit that function 4 key and bring that down. Again, use dollar signs and bring that down.
So we bring the compensation down, change the format to dollars, no decimals. There are, you can go out decimals, but it's not important. What I like to do is not round, but I like to keep the pennies there. I know if you look at this last number, it goes out several decimal places, but there's a couple reasons. I mean, it can be a little tricky. If you don't round, then it's possible when you add a column of numbers, because of rounding, it'll be off a dollar one way or the other. So so this is a challenge if your boss is real picky and getting a calculator and adding things. However, if you use the round function, which is possible to use the round function, you just do equal round and you tell them how many decimal places you want. You can go 0, but I don't recommend that you do that, because if you use the round function, we're going to have a break-even case where we're going to tell Excel change one assumption until it makes my net present value 0. And if you use the round function, Excel can't find a solution because it can't find one that exactly rounds the 0. And so it's a give or take. It depends on how picky your boss is. What you can do if you're worried about your boss taking a calculator and adding the numbers, just put a asterisk. Sums may be slightly off due to rounding or something like that. Because it could be off by $1, probably not more than that. But just because there's 40 cents and 40 cents and 40 cents, and that adds up, that adds an extra $1 at the end. So there's our compensation. There's one thing I forgot to do at the very beginning, and let's go back and hit that. On the transactions, I have 80,000 transactions, but if you think back to the assumptions, 80,000 is the number they do in total, but we have 3 cases where we're going to say they convert 70%, 90%, or 50%. This is our base case. So what we're going to do with the transactions, if you go back to this formula, we're going to take just that very first cell, is the only one we have to change, and we're going to take B6 times B9, the 70%, and we do that, that will adjust all of our numbers. We don't have to adjust these others because they're just growing by a constant rate, so as long as the first one's correct. And this first cell is really important because that's where we're going to run the best case and worst case. We'll only need to change that one cell. All we need to do is figure out that compensation is per person. So what we want to do is get our total saved. So we're going to put in this cell total saved. How much did we save? And our total saved is going to be the 2.8 FTEs times our compensation. So bring that formula down. So look back, this is real important. On the total saved, you can just copy that down. So if you look at the formulas, let's go back to what we have here. So in this first cell, we have assumption B6, which is the 80,000, times assumption B9, which is the 70%. Sorry, I've got other stuff in there and it's just not letting me show the formula. Then we're going to bring that down by multiplying B9, the 56,000, times our growth in assumptions. All right, so that finishes out this first column. I'm going to take this out, so if you need it, hit pause on the video. Take that out, and take that out. The next thing we do is we take the 56,000 and divide it by how many transactions each person can do. The B7, remember B7, each can do 20,000. So that tells us how many FTEs we can save. That one we can just copy down. So delete that one. The compensation, we take total compensation times the 1 plus 15%. That gives $57,000, and then we inflate that by whatever the assumption is from payroll on how much our pay is going to increase. So those are those two assumptions. And we get our total save, which is just a number of FTEs times how much we pay each FTE, including the 15% extra compensation. And it gives us our total saved. And so what we're going to do is we're going to call this benefits. And what I'm going to do, I'm going to highlight that and do Alt HMC to center it. Give it some colors. So I like green for benefits. So there's all my benefits, my total amount saved. So I'm in good shape there. So now we have our cost. Now on the cost, I'm going to put my cost right here, and we have two costs. We have the software development and other, and our other is zero because we don't have any other costs, but I'm putting other in there. Now for your cases, this section here, all these columns that add up to total saved, you might have 4 columns, you might have 10 columns, you might have 2 columns. On the cost, I have 2 columns, you might only need 1, we only needed 1. I put 2 in here just to make sure we, if something else came up. All right, so for the cost, I have these 2 columns. I'm going to highlight this in red and use yellow text. I'm going to center these 2. And then on cost, I'm going to do Alt HMC again, just to center it. I probably should have, and I don't have here a total cost. I didn't do that. That was a mistake in how I have it set up. But with total cost, you need something that adds these costs all together. But it's fine the way it is. So the only real cost we have here is the software development. That happens at time 0. So I'm going to do minus. I'm going to go over to my assumptions and pick up that, and that gives me my total costs for software. I don't have any other costs. You could just type 0 down if you want to on that. I don't like having typed numbers in here, but if it's just zeros so people can tell that you don't have any other costs, that's fine. So there we have our benefits and we have our costs. So now what we do is have our net cash flow. So our net cash flow is right here. Our net cash flow, we're just going to add across. We're going to take the total cost plus the total saved. Obviously, that's just going to be the total cost in the first column. We can now drag this down, and that gives us our total net cash flow. I'm going to put this in blue with yellow text. Again, use your own format. So what I'm doing is green for benefits, red for costs, and then blue for calculations, but whatever format you want to use. So there's my net cash flow, and so now we can actually get some calculations. So I'm going to go over to A15, and in A15 I'm going to type net present value, and then in C15 I'm going to use a formula, and what this formula is equal XNPV. So XNPV, you want that function, and then Bill Gates tells you exactly what you need to do. you start off with your rate. So we go back to the assumptions. We find our discount rate. Hit the comma. Go back to your base case. Be real careful here. Anytime you switch pages, they put the name of the sheet that you go back to, which is base case. We do not want that to say base case. So anytime that happens, it's okay for it to say assumptions because we always want it to be the assumption page. But when you flip back, you don't want it to say base case. The reason is when we create the best case and worst case, we don't want it going back and referencing the base case. So here, the second thing they want here is the values, where our values are right here, our net cash flows. So bring those in. And then the last thing they want is the dates. Now my dates are different than the earlier part of this video because I had to update this video. And so the dates changed. Your dates will be different too. That's not an issue. Whatever today is what you're going to have. So you're fine. So sorry, it's going to look like it just shifted on the video, but we're fine. So those are the things that you want there. Let me copy that over so you can see it because that's a kind of a massive formula there. And when you do that, you get a net present value of $245,814. Now what I'm going to do is I'm going to ask the question, is that good or bad? So I'm going to do equal if my net present value, so here's the rule on net present value, if it is greater than 0, then we are going to accept the project. Otherwise, if it's not greater than 0, now we can get really precise and say if it's greater than or equal to 0, we accept. Because if it's equal to 0, it's still an acceptable project. That means we're making exactly our 7% cost of capital. The chances of it equal exactly 0 is very low. We'll put it in there just in case. Otherwise, we reject. And so here we're going to accept. I'll put that formula off below this one just so you can see it. We'll have to move it here in a second. But there's your two formulas that we have. 245,000, that's acceptable. It's great, much greater than 0. All right, so there's the first thing. The second thing we want to do is the internal rate of return. And with the internal rate of return, what we do is equal X IRR, open parentheses, and you select the values, comma, and the dates. And it says at the end that it wants a guess, but you don't need a guess anymore on here. So you just hit enter. Make sure you change the net present value to dollars with no decimals. And you change the IRR to percents with 2 decimals. All right, so I've got to move this function up. I'll put it up here. So on the IRR, what we say is equal if. Now, how do we get, what is the IRR rule? The IRR rule says if it's greater than or equal to our cost of capital. So we go back to that cost of capital, the 7%. Go back to the base case. Again, remember when it types the word base case, you want to take that out. I wish Bill Gates wouldn't do that. It doesn't really help you, so you don't want to say base case. So if it's greater than, so if your return is greater than 7%, you're going to accept. Otherwise, you reject. So there's your answer there for IRR. You can put the formulas in so you can see them. You can hit pause if you need to here, but there's the formula for IRR. It's XIRR, and then the accept reject. So there you have it for net present value. There you have it for IRR. I want to erase these formulas, so if you need it, hit pause on the video and you can see the formulas. All right, the last one we have is discounted payback, and this is the one that's really involved. So we're going to go over here and we're going to put some columns in here. Look at what we're going to type. The first thing we're going to do is the cumulative net present value. Then we're going to do the incremental net present value. And then we're going to do percentage of year used. All right, so you have to type all of that in there. I'll use the blue again with the yellow text. These are all calculations. So cumulative NPV, incremental NPV, and percentage of year 2. So at time 0, our net present value is just negative 565. The next period of time, our net present value is going to be equal x NPV. Remember, we do the rate. So our x NPV, we go to the assumptions, click on that, hit the comma, come back to the base case. Remember, take that base case out, and you want to highlight your first two values, comma, go over and highlight the first two dates and hit enter, and that gives you, let me put that off to the side because that is a pretty massive formula there. It's the same formula we did before, except for now we're only doing it, it's the exact same formula, we're only doing it for the first two periods. So what we want to do is we want to be able to copy this down. So we want it to always be B15. So put a $sign before B15. So when you copy it down, it will always reference 15 on the assumptions page. And then as we go down, we want it to always be row 8, but we want the 9 to go 9, 10, 11, 12, 13. So we want that to go all the way down. Same thing here. So you want to, with this formula, let's see if I can get the whole thing in there. It's going to be a little tough. Let's move off to the side here a little bit so you can see all of it. Ah, it's not going to fit. There it goes. All right, good. So you want this formula. You're going to do the exact same net present value that we did before. We're just going to make sure we always reference row 15. So as we copy it down, it stays on 15. There, I got some base cases in there. So you want to take the base case out. Anytime you see base case, you want to take that out. Let me take it out of my formula here. I didn't catch that. So yeah, you never want to have the word base case. So you go all the way through the exclamation point. All right, so that's what your formula is. And now you can copy that down. And the very last one should be your net present value. You remember that number 245,814? That is our net present value. So that works really, really well. All right, so there's that function. I'm going to delete this because I need this space. So hit pause if you still need that formula. All right, so what we're going to do here, we're going to do the incremental net present value. And by that, what we mean is how much did our net present value change from time 0 to time 1? And this one's really, really simple. All you do is you take the net present value this month, this year, 409,370, and subtract what it was at the end of the previous year. So that means our cash flow was $161,000, but on a present value basis, it was $155,630. And that formula we can just copy down. At the very beginning, you have obviously the negative 560,000. So if you were to highlight this entire column, it should add up to 245,814. This column essentially adds up to that column. We could have used this column to calculate our net present value, but we didn't. We did it all in one formula. All right, so that's pretty straightforward. Now we're going to get to the tricky part. On the tricky part, we're not going to use this first cell at all because time 0, what we're going to ask is, let me walk you through this formula. I'm going to use the formula I'd already built in the previous one, and I'll walk you through it, walk you through the logic of it versus redoing it from scratch. So what we're going to do here is we're going to come over to column I. What we're looking for, let me explain discounted cash flow, a discounted payback. Discounted payback, what it's saying is when in this project did this project go from negative to positive? And we can kind of tell just looking at it somewhere. So at year 1, still all negative. Year 2, negative. Year 3, negative. Sometime during year 4, the project went from negative to positive. We're trying to find exactly that point. where the project went from negative to positive. And we know it's sometime in year 3, but exactly where in year 3. So what we're going to do with this formula, if you look at it, what it says is if the current year is still negative, then we need 100% of this year. So we haven't gone positive yet. So year 1 is definitely not our discounted payback. But if the current year is positive, then we ask, well, was the previous year positive? If both years are positive, like we have in year 4 and 5, here year 4 is positive, year 5 is positive, so we don't need any of year 5 if we were in this case. But here it's going to give me a 1 because the current year is negative. So what we're doing here at the end, we're saying if that's less than 0, the current year is less than 0, give me a 1. So we're in this F, which means the current year must be positive. Then we ask, well, is the prior year positive? If both are positive, we put a 0. We don't need anything. So we're in this very, very last part of this if function, which means the current year must be positive and the prior year must be negative. If that's the case, what we're going to do is we're going to take the cash flow, how much it was negative. So it doesn't count in this year. Let's look at this year and we'll see. It's $88,000 negative. So at the end of year 3, we need $88,000. And year 4, we have $165,000. So we're asking how far into the year do we go? Remember when we said these cash flows are evenly distributed. So how much of the year will you need to go into until this $88,000 is taken care of with this cash flow? So we just take the deficit at the previous year, we use the minus sign because we want a positive number. So minus that deficit divided by our incremental cash flow this year. And when we do that, if you look at the numbers, it'll probably make more sense when you look at the numbers. When you look at the numbers, you can see 88,000 divided by 165 was 53% of the year. So we needed 53% of the year for this project to go from a negative net present value to a positive net present value. All right, and there's the formula there. I know it's a little bit messy, but it's kind of a long formula, but pause so you can get this set up. Make sure you're getting these numbers. If you're getting these numbers, you're in good shape. All right, so hit pause if you need to. I'm going to delete these now, so hit pause on the video. So the discounted payback is simply all we got to do is sum those numbers, and so our discounted payback is 3.53 years. You see in our assumptions, we said the rule was 4 years, so we can now set up, let me put the formula over there. So we can now set up the accept reject. We can see equal if, and here what we're going to do, equal if this 353 is less than or equal to our payback cutoff 4, comma, come back to the base case, eliminate the base case, and then put accept, otherwise put reject. So this one's acceptable because it is less than the criteria. So there's that formula. Oh, let's spell the word reject correctly there. So there is the accept reject all the way down. I don't know why I'm getting different formats there. Let me paste special formats so they all look the same. There's my accept reject. So we've got everything. If you want to color code and all that kind of stuff, you can certainly color code, and accept is green, reject is red. But that gives you everything you need to start running the sensitivity analysis.